Thank you, Simon. Thank you for the invitation to this workshop. And I'm really happy to be here and connect with you and are able to share different ideas and strategies that we could implement in different climates all around the world. So I'm Michela Battaglia, the founder of Sustainable Building Now, that is a consulting company on bioclimatic and passive design strategies. Today, I will share with you how we can shape sustainable design with the Givoni Bioclimatic Chart. 1 second, it's blocked. Take time.
So yeah, is there a little button on the bottom of your screen, like 2 arrows left and right?
Yeah, I'm no, but how it's blocked now. Let's see 1 second.
It's okay. Otherwise, I can bring up the presentation.
One second.
I'm just going to see if I can bring it up as well.
I'll try to.
Right, sorry about this, guys. It won't be 2 secs. Right, I'm just downloading it. It worked previously when we went through this. So
okay. No, now it's going.
is it? Cool.
Perfect.
Fine. Okay.
Okay. So first, let's see what is a bioclimatic architecture. So when we talk about bioclimatic architecture, we refer of a building that is designed based on the local climate and environmental condition to achieve thermal and visual comfort and minimizing energy consumption. The main principles of bioclimatic architecture include site and climate analysis, orientation and window placement for solar control and shading, natural ventilation, thermal mass insulation, lasting technologies, and also the integration of renewable energy. Let's see what is the evolution of bioclimatic architecture. The concept of bioclimatology was first mentioned in 1930s. Then Victor Oligai, with his paper in 1953 and with his book in 1963, he started to analyze the comfort zone based on different climate zones. So he developed this bioclimatic chart that you can see on the right that provide tools for architects. Then scholars like Givoni and Zocolai expand the Oligai works, focusing on comfort zone derived from psychometric data, reinforcing climate adaptive design. How you can see here on the right on this chart, this is the chart developed by Givoni that help analyze thermohygrometric condition, focusing on temperature and humidity to enhance building design in line with local climates. On the vertical axis, we can see the specific humidity. On the horizontal axis, we can see the dry bulb temperature. On the curves, I represent the relative humidity, and then the chart is divided in 14 zones. For each zone, we will see later that we have passive design strategies that we could implement. So starting with the zone 1, we are in the comfort zone that generally is between 22 and 26 degrees Celsius. We are talking about Celsius. I don't know, maybe some people use Fahrenheit, but here now we are focusing with the Celsius degree, and with around 40 and 60% of humidity. Then there is the zone 2, that is this one, that is the comfort zone permissible, and maybe to achieve the thermal comfort, we could need to open windows or adjust clothing. When we are in the zone 3, it means that we can heat the interior of the building with heat gains, such as lighting or human activities, or, for example, other activities. In the zone 4, we are in passive solar heating. So it's really important to use well-placed windows and solar wall or greenhouses to allow sunlight to enter and naturally heat the indoor spaces. In the zone 5, we could use the passive design of active solar heating, installing solar panels or thermal collectors to actively capture solar energy and convert it to heat for the indoor spaces. In the zone 6 here, we is where the humidity, so we need some humidification system to increase the moisture levels in the air. And then in the zone 7, conventional heating is the case where the temperature is so low, so the only way to achieve thermal comfort inside a building is using a conventional heating system, like, for example, radiators. When we are in the zone 8, that is this one, you can see here, and start from 20 degrees. Now, maybe using such type of glaze that have low SHGC value, like, for example, 0.3, and reduce the solar heat gain, we can achieve to 24 degree, but generally starting to 24 degree, depending on the type of glass that we are using, it's really important to use solar protection in front of the glazing part of the building, the glazing facade. Then in the zone 9, we could implement the strategies of high thermal mass cooling. So it's really important that all the thermal mass need to be inside. So, for example, we could use the wall inside our building that have high thermal mass. Can be material like cement, rock, adobe, that store the heating and then or cool and then release with the time. It's really important in this case that these materials are not in contact with the solar heat, because in case this material will be, how I was saying before, can be heated. Then in the zone 10, this one, we are in the zone where we could use the evaporative cooling system, like, for example, use of water spring, evaporative coolers or fountains or pods. Then in the zone 11, we could use the high thermal mass with night ventilation. That is mean that user material also with high thermal mass in combination with nighttime ventilation to cool the building by releasing stored cooled airing during the day. In the zone 12, we could use natural and mechanical ventilation. For example, using open the window, use wind towers, or also fans or other type of mechanical ventilation. Then in the zone 13 and 14 are the zone where the temperature and the humidity is so high, so we are not able to use passive design strategies to cool down the building. And the only way to cool down the building is using this system. But all this part that we can see here, we are able to use passive design strategies, while in such case, in the zone 7, in the zone 13 and 14, we have to heat or cool down the building with the normal system. Let's see now an example of Dubai. I start to analyze the such days like, for example, 21st of December, 21st of June, then the most hot day of the 2022, that was August 9th, and the coldest day that was on January 7th. For every day, I start to understand every 4 hours what are the temperature and the humidity. Then let's make an example. For example, 21st of December, we have the temperature of 23 degree with 50% of humidity. And in this chart, I start to make this point. This I do it manually, but then we will see later that there is also a program that you could use to to understand also fastly how can be the strategies that you could implement. The same for every 4 hours, then I connect the point and see in that day in what area we are and what can be the strategies that we could implement. I mean, I did the same for these 4 days, and here I understand that, for example, in the December 21st, we have in comfort zone 1, comfort zone admissible 2, and then in zone 8, where solar shading on glaze system is essential. On January 7th, here, we are here. The environmental conditions fall into comfort zone 1, permissible comfort zone 2, and zone 3, where the building will heat itself through internal gains. Here, you can see here, 3 heat internal gains. Then on June 21st and August 9th, are the case where the conditions are mainly in the zone 11, where we are able to cooling with high thermal mass and night cooling. And also we are in zone 3, where it's essential to use air conditioning. This is the program that I was told before. You can use this free, it's a website actually. The name is andrewmarsh.com, and you can upload the data climate everywhere around the world, and then the website create for you this graphic, and here you can see for each month in this is an average. Okay, so generally I prefer to use both this online website and also the chart that I did manually to understand what can be the worst case on that day in that year, for example, that I want to analyze. Here you can see that during the winter in Dubai, we are in comfort zone, but also in the zone internal gain. We are also here in the zone of natural ventilation, mass cooling, and only in such case we are in during the summer. We are in the zone 13, where we need air conditioning and humidification, because here in Dubai the humidity is really high. For example, using passive design strategies, we are able to all the year here not open air conditioning, but for sure, if we're using a glazed facade in a country like Dubai, where it's always hot, then the glazed facade reacts like a radiator. And do we really need a radiator in a climate like Dubai? I don't think so. But here, people love the view because it's luxury, it's cool for sure, but this is not sustainable in a country like Dubai. actually, during the summer, I opened the air conditioning only a few hours during the day, also in June, July, and August. And this is why, because where I live, the apartment have a high thermal mass inside. It's on the north facade, the view of my apartment. And then I open the fans. So also we have to think sometimes, I really need to open air conditioning. Maybe I can open a fan. Maybe it's okay. Let me try if I could open first a fan, and then if I can't, I feel so hot, then okay, I have to open air conditioning for sure. But it's better first to try different way to reduce the consumption of a building. This is, for example, a strategies that can be implemented in Dubai. It's really important to use solar shading always in summer and in winter on all the glaze facade. And also it's better to avoid large glaze areas, also for the U value that is completely different, a U value of a glass than a good wall, no? It's also really important to avoid glaze facade on east and west in the building in Dubai, because here in summer the solar gain is direct in during the morning, and during the afternoon on east and west facade the solar rays are direct on the facade. And the temperature also at 7 of the morning, it's around 38 degrees Celsius. And this is really crazy, let's say, because if you use glaze on east and west facade, then the interior of the building will be really, really hot inside. Then, for example, can be implement passive design strategies of ventilation. The ancient civilization in this country know about the wind tower, because here in Middle East and also in Iran, they invent the famous wind catcher. They used to, in past, they used to use the wind catcher to cool down the interior of the building. For the it's really important as well to use, how you can see here, the high thermal mass inside a building. So using material, how I say before, like cement, adobe, rock, and also incorporate material like calcium chloride. Calcium chloride is a type of salt that you can also find when you buy a new pair of shoes, okay? And they used to put this material inside the box to keep the humidity. The same can be done here. For example, incorporate the calcium chloride for absorb the humidity in some wind catcher or other type of ventilation system. Let's see now in an example in Miami. In Miami and Dubai, the temperature is similar because they are more or less at the same latitude. So in here we in the 30th of January was the coldest day in Miami in the year 2021, and but was only untypical day, because generally in Miami the temperature is almost in a comfort zone during the winter. Also sometimes, how you can see here on 21st of December, that is winter there, we are in the zone 11 and 12. While during the 18th of August and 21st of July, we are also in the zone 11, and in zone 13. So in sometimes, yes, we have to open the air conditioning, but in some case we could use thermal mass and natural ventilation to cool the interior of the building. Here, using always the same website, andrewmarsh.com, you can see for each month what is the average in what area we are. So you can see here that we are in comfort zone, but also we are in the natural ventilation zone and in the mass cooling with high thermal mass zone. So incorporating high thermal mass and natural ventilation, and also how you can see here, natural ventilation from here, high thermal mass inside the building, and also incorporate shading system on the glaze part of the building, we can achieve thermal comfort inside the building. In Miami, we could also use calcium chloride because it's also a humidity zone. And we could also keep the cool underground. This is because this is not possible in Dubai because the underground is too hot also in winter. But for example, in Miami, the temperature of the underground at less 6 meters is around 24 degrees Celsius, 24, 26, depend of the also of the type of underground of the material. Here we are in Valencia, Spain. It's a Mediterranean climate, and generally here, if you really designed a good building with incorporating all the passive design strategies that you can see here, so for example, natural ventilation, mass cooling, we really don't need to use air conditioning. Never. I lived in Valencia for a few years, and I only use a fan during the summer, and also in winter here. I never open some radiator. Maybe sometimes here, no, because this is the case of solar active design strategies that implement like a solar panel to heating the interior of the building. In the house where I lived before, there was no solar panel, so sometimes in the winter I use some radiator, electrical radiator that I open sometimes. This is, for example, an well-designed building using passive design strategies. This is a building designed by the architect Luis de Garrido. He implement here high thermal mass with using material with high thermal mass. Also, all the glaze part in summer are covered by a solar shading system. There is the underground that is in contact with the building and help to take the building cool during the summer. And also he incorporate natural ventilation, designing some opening here that you can see here, then the air enter inside and escape from the upper part of the building, creating this updraft. You know that the hot air always go up because it's less at a less density. Here is the case of Coober Pedy in Australia. Here we can see that during the summer, we are in the cooling evaporative zone and in the high thermal mass zone. And in the winter, we are in the heat internal game and solar and active and passive strategies. Let's see here. Okay, this is the main graphic. You can see also here we are in, this is the evaporative cooling zone. There is the mass cooling zone. And here, when we are here, we could study to implement also this type of strategies, while in winter, it's really important that the sun enter inside of a building to be able to heat the interior. This is a strategy that can be implemented in arid climate such Coober in Australia. Here the also can be used wind tower and evaporative cooling system, high thermal mass, and shading system. It's blocked again. Let's wait 1 second.
Okay, let me just see if I can find the presentation quickly.
No, okay. It needs time. Okay, this is an example of strategic building for arid climate. This is not in Cooper Pedy, but it's in Canyon Visitor Center in USA. So we are in the Canyon area. And the designer designed this wind catcher, incorporate inside evaporative cooling pads. The interior of the building have also high thermal mass, and for the winter when the temperature is low in the canyon, they also use this tram wall. That is a wall that also have a high thermal mass and help the building to keep heat during the winter. This is another example of a building strategic techniques for arid climate. Here the architect, Luis de Garrido. If you are interested, he do a lot of bioclimatic architecture all around the world. So you can go to his website to they have a lot of explication about the strategies that he implement. And he create here this wind catcher that then is in contact with the underground. And then when the air escapes, there is a spring that help to cool down the interior of the building. And then there are this opening for that create updraft for cooling down the building. Here we are in Rome. Also, Rome is Mediterranean temperature, and if we really if we incorporate passive strategy design, we are able, how you can see here, to not open air conditioning. Else also don't open the heating during the winter. Here we can see that also we call implement natural ventilation and high thermal mass. This is a typical example that also can be implemented in Rome during the summer. It's also important to use certain system, cooling with high thermal mass. The insulation have also to be put outside and never inside, because it's really important that the thermal mass is in the internal part of the building and not outside. Then we could create some opening in the other part to create for example, this stack ventilation or cruise ventilation, depending on the case. This is the case for winter in Rome, where we need only also the solar gain of the sun to heating the interior of the buildings, but also high thermal mass material inside the building. This is a case of bioclimatic architecture made from the architect Mario Cucinella. He designed all these balconies in the way that during the summer, the sun never enter inside the building, but yes, during the winter. And also he create opening that allow the natural ventilation. Here's the case of Milan. In Milan, also the winter are really, really cold. I don't know, maybe are similar to London, because there is there is not a lot of sun during the winter. It's always cloudy, so can be a similar climate between London and Milan. So it's really important to understand how to heat the interior of the building, creating, for example, system that like for example this one, okay, using the tram wall that absorb the heating and then release with the time. Also using material with like rock, for example. All these materials that have high thermal mass help to store the heating from the sun and then release with the time, also during the night. In summer, how it's similar to Rome, it's the temperature is hot, but not too much. So incorporate only shading system, natural ventilation, and high thermal mass. We are able to cool down the interior of the building. This is an example of always of the architect Mario Cucinella, that is a pioneer of bioclimatic architecture in Italy. This is the Unipol group headquarters in Milan. During the winter, the double screen glass react as a bioclimatic greenhouse, helping heating the internal temperature. Also in summer, they open some part of this double skin glass in the way that the ventilation, in the way that the interior of the building will not be heat from the sun. So using the passive design strategies, we are able to minimize from 20 to 90% in some climate the use of heating or cooling system. Sometimes we could have some challenges that can be some limitation. For example, can be microclimates problem, or the changes of the pattern of climate. Also can be some financial limitation or regulatory issues, because not all this design can be implemented in some countries, but generally understand what type of passive design strategies we can implement, what we could use. We are really able to create a bioclimatic architecture and able to use less energy inside our building, using, for example, less cooling on passive system. So I'm Michela Battaglia. I'm the founder of Sustainable Building Now, that is a consulting company on bioclimatic strategies. These are my contact if you want to connect with me in LinkedIn or Instagram. I will be happy.
Fantastic. Thank you very much, Michela.